Modules, an easier way to share scripts. In this nugget, we're going to be talking about the new modules functionality in Windows PowerShell version 2. We'll start by talking about what modules are, where they live, and how you use them. And we'll look at two distinct types of modules. Binary modules, which are usually what's produced by a .NET framework developer working in VB or C#, and script modules, which are something that you can create using PowerShell's own scripting language. And we'll also talk about some module management and some ideas and best practices to help you use modules more effectively. So what are modules? Well, let's kind of talk about what modules aren't. It used to be in PowerShell version 1, the only way you had to sort of officially extend the shell was something called a PS snap-in. And I can run get PS snap-in, and you'll see all the snap-ins that are currently loaded into the shell. And most of these are ones that came with Windows PowerShell. If I run the command again with -registered, you'll see that I don't have any other snap-ins registered with the system. So if I tried to run add PS snap-in, well, there's nothing left to add. And that was actually kind of the downside of snap-ins, is that you had to install them and register them. They had to kind of announce themselves in advance so that PowerShell could see them. And it's not an ideal way to distribute software. Sometimes you just want to be able to copy something from one place to another. And there's more to a snap-in also than just its DLL. Snap-ins can come with help. They can come with help files so that when you run something like help get AD user, help shows up. They may come with some type extensions. They may come with some formatting views so that when I run get AD user filter star, I get some predefined layout. It just doesn't have to list every single property of every single object that it finds. So snap-ins kind of needed some supporting characters to go along with them. Well, and that's where modules are designed to help. Modules solve two problems. Number one, they provide a way to sort of wrap not only a DLL, but also all of its supporting things, help files, type extensions, formatting views, and so forth, to kind of package those into a single way. And it builds them in such a way that you don't have to register them in advance. It's just a simple file copy to get them to wherever computer you want them to run on, and then you can bring them into the shell. Now that does bring some restrictions. Let me change to the PowerShell home directory. PS home is a built-in variable. It contains the installation location for Windows PowerShell. And if I get a directory listing here, you'll see that I have a modules folder. Now that's there by default. And all modules must reside in that location. So if we cd modules, get another list, you'll see that there are several that come with Windows Server 2008 R2. I'm going to look at the Active Directory one. Actually, heck with that. I play with that a lot. Let's look at the group policy one. Now there's a couple of important conventions here. The name of the folder is the name of the module, so it is group policy. And in here, you'll notice I have to have the module's file has to have the same name. So if the folder is called group policy, then this file has to also be called group policy. And you'll notice that this does come with a formatting file, so it defines some views, and it's got an English file. Let's see what's in that ENUS. Probably some localized strings. Oh, it is. It's the help. It's the English, the US English help for the commands that are defined by that particular module. So this is a binary module. And I can tell because the file name extension is .psd1, and that's a manifest. So let's just open that up in Notepad. This is what a manifest looks like. First of all, notice that it is signed. Microsoft likes to sign all their code, and so this carries a digital signature from Microsoft. That way, if anybody tampers with this file, PowerShell will stop loading it. It will know to check. And if you have your security on PowerShell, your execution policy set to the all signed policy, which is a good one to use, then this will still run. But this doesn't actually contain any code. It's just a manifest. It's telling me the author's name, the company, the copyright, the module version, the version of PowerShell it's meant to run on, the version of the .NET framework that it requires in order to run. And here is the nested module. This is the actual DLL where all the commands come from. In the old days, we probably would have called this a snap-in, and there would have been an installer, and it would have registered itself, and we would have used add ps snap-in to load it. But with these modules, it's all packaged this way. Now it also says that when you load this module, you also need to load this formatting file, which is the one we saw down there. There it is, grouppolicy.format.ps1xml. and it requires some other assemblies in the .NET framework that it's going to look for. So this is just a way that PowerShell can check to make sure everything that this module needs, all of this module's prerequisites, it can check to make sure that they're there before it actually loads the module. So all I have to do to run this is import module group policy. When that happens, PowerShell knows to go to the modules folder and look for a subfolder called group policy. And within there, it will look for several different files, starting with the PSD1. That's the manifest. Once it finds that, it opens it up, reads it, and that tells it where to go find the actual DLL. It tells it to load this formatting file also. And PowerShell's help system already knows that because the manifest is located in this place, then the English help will be located under a directory called en-us. So those are binary modules, and that's the majority of what you'll see Microsoft distributing. If you're an application developer, you can certainly get into Visual Studio and use C# or Visual Basic to create your own snap-ins, your own DLLs for Windows PowerShell, and you can package them as modules. And by and large, you can just copy what's already there. Grab one of the existing manifests from this folder. Let's go look at Active Directory. Grab its manifest. You can see that it not only has a format file, but it also has a type extension, and there's some additional resources in this DLL. So if we notepad just the PSD1, this one does not carry a digital signature, which is actually kind of strange. But it is telling it to load the Microsoft.ActiveDirectory.management DLL. Here are the required assemblies. It wants to process this type extension and process this format extension. You can have multiple ones listed there. That's why it's called types to process. So if you're a developer, you can create one of these binary modules on your own by just kind of copying what Microsoft has done before you. But what if you're not a Visual Studio developer? What if you're just an administrator who wants to write some scripts? Well, that's what script modules are for. So let me walk you through a fun little example. This is a script commandlet that I wrote, and actually this was from the previous nugget, so hopefully it'll look familiar. And I've got this get inventory function that's designed to work like a commandlet. It's got a parameter -computer name that's mandatory and can take a value from the pipeline either by property name or just by value. Within here, I've modified this a little from the previous version you saw in the previous nugget. I've also added this test host name function. And what I do with this is I don't want to attempt to do something with WMI on a computer that isn't available on the network. So I'm just going to ping it first. In this test host name function, I'm just using the built-in test connection commandlet, but I'm grabbing the results and I'm checking it. It pings it, I think, 4 times by default. I'm checking the status code of the first ping, and if it's 0, I'll return true. Otherwise, I'll return false. So up here, I'm just checking if I returned true from the ping, then go ahead and do everything. If I returned false, then just skip that computer. So this is something now that I want to distribute. I want to share this with lots of people. So here's what I'm going to do. I'm going to save this in the modules folder. So I need to go to C, Windows, System 32, Windows PowerShell, version 1, modules, and let's just make a new folder here called inventory. And I'm going to save this, but rather than saving it as a PSD1, because that's just a module manifest, now remember I named it inventory, I'm going to save it as a PSM1. And you can kind of get the reminder down here. PS1, that's a script. PSM1 is a script module. PSD1 is a binary module. And PS1 XML is a configuration file. So by saving this as PSM1, there it is, I can hop down here in the shell and say import module inventory. And it will. And now if I look at my function directory, dir function, you can see that I've got my get inventory function. And here's the thing I'm not a big fan of. I also have this test host name function. So here, let's remove module inventory. Get a directory again. Okay, make sure those things are gone. They are. Nice. My goal is to kind of only expose get inventory, and I want it to look pretty, so let's actually uppercase it. And I might even, like we discussed in the previous module or nugget, I might come down here and put some comment-based help in here so that I can really make this look and feel like a real commandlet. But test hostname, that's just kind of an internal thing. I don't want that to be exposed to the rest of the world. I don't want them to see that. So I've got two choices. One, I can take this, cut it to the clipboard, and I can paste it inside my process script block. This makes the test host name internal to my getInventory function. You won't be able to see it from outside. The downside of that is, this inventory module has got a lot of fun stuff, and I've got other things I plan to put in here in the future. I have one I want to do a get disk space. I have another one that I want to do that's get user info. And I think all of them are going to use this test host name. If I stick it inside getInventory, then it's hidden in there, and I'd have to copy and paste it into every single function that I wanted to use it. And that's just a lot of repeated code, which is a bad idea. I mean, if I ever change this, I only want to have to change it once. So I need a way to have it in here at the top level, but not accessible when I import this as a module somewhere else. So the trick to this, let's get command, and everybody who uses a noun like module, is export module member. So let's ask for help on export module member. Export module member allows you to specify which functions are exported from your module. In other words, which functions inside your module are made globally visible. By default, when you import a module, it imports all of your functions. And that's what you saw before. If you explicitly export some of them, then only those ones are brought into the shell. This is probably way easier to actually show you than just to talk about. So down here at the end, I'm just going to export module member function get-inventory. So by explicitly exporting one, I am telling it don't export anything that I did not explicitly export. Since I didn't explicitly export this one, in theory, it should be hidden. So let's go back down to the shell, import module inventory. Now let's look at the function drive again. There's my get inventory, and notice that it preserved the case I chose, and you don't see test hostname at all. Not in here. So I'm able to keep that one private by explicitly exporting the ones that are going to be public. Now if we look at the help for that again, help export module member, you can not only export a function, but you can also specify aliases for them, so you can have this create aliases right there. You can even export specific commandlets. You can export variables if you want to add to the shell's automatic variables, and so forth. And it even tells you here, if a script module doesn't include an export module member, then all of the functions are exported, but the variables and aliases are not. When the script module includes export module member, only the ones that you specify are actually output. Now you've got a couple of options in the ways you could use that. You could make this a comma-separated list. So if I had another one that was get drive inventory, then I would just make a comma-separated list and it would export all of those. I actually don't like to do that. I know it seems like a waste, but just because I think it looks clearer, I have a separate statement for every single one that I want to export. You can do whichever way you like. Lots of people much prefer having one line, one command, and you just specify the comma-separated list, and that's fine. I just like them all stacked there at the end, because that way if I need to add one, it's a simple copy-paste. I don't get a long command line that's scrolling off the right edge of the screen. And if I need to remove one, it's easy just to remove that line instead of having to go edit within the command. But, just my preference. And pretty much that's how you manage those modules. If we go back to that list, GCM, we've got import module, we've got export module member. New module and new module manifest can help you create these things at runtime. Remove module will remove it. If you're a developer and you've made a module manifest, a PSD1 file, and you want to test it to make sure it's formatted correctly, test module manifest will load it. It'll look at it without actually loading the entire module. It'll just bring that in and attempt to parse it. And the last thing you can do is see what modules are loaded with get module. I've got Active Directory, Group Policy, and Inventory, and it tells me that this is a manifest or binary type, and that this one's a script module. So lots of great functionality. It's a nice, easy way to wrap a script up too, because all you have to do is copy that whole inventory folder from one computer to the next computer, making sure it goes into the PowerShell directories modules folder, of course, and everything goes along with it. There's no installer, there's no registering, nothing else. Nice, simple file copy distribution. In this nugget, we explored modules, a new feature of Windows PowerShell version 2 that makes it a little bit easier to encapsulate, repackage, and distribute code, including scripts. So we talked about what modules are, and keep in mind that PS home trick I used. That's a built-in variable that will get you to the PowerShell installation folder. And keep in mind that your modules have got to live under the modules folder in that location. We talked about the two main types of modules, binary modules and script modules. Binary modules are sort of an ongoing or going forward replacement for the old PS snap-ins. They work the same way, and you can still use a binary DLL, but you don't have to install it and register it in advance, which is really nice. Script modules, of course, are what you can make using Windows PowerShell's scripting language. And you can either allow every single function in your script module to be exposed, which is the default, or you can explicitly expose certain ones, reserving the rest of them as sort of private internal functionality. And we talked about module management, importing and removing modules. Keep in mind that they are global to the shell, so even if you import one in a script, it'll stay loaded for the duration of the shell. There's a couple of built-in modules in Windows Server 2008 R2 in particular, the Active Directory one that I just have importing right in my profile, so that every time PowerShell loads up, I always have that Active Directory module. I hope this has been informative for you, and I'd like